Okay, so in this video, we're going to take a look at monopoly. And the first question is just what's the difference between a natural and an artificial monopoly? Natural is one where throughout the range of, let me back up. Throughout the range for which demand exists for the product, ATC is downward sloping. So that's the technical definition. But what it really means is just like that the demand for this product, right? You've got a demand curve for the product. In that entire area where it exists, the ATC for this company is getting lower and lower as they ramp up production. So it actually means that it's natural for them to have one company to provide this service. It would increase costs if we didn't have a natural monopoly in those cases. Like if we split it up, it would make it more costly for everybody. An artificial monopoly, on the other hand, is one created through combinations or copyrights, and it looks like a U-shaped ATC is kind of the easiest way to describe that. So, in fact, I'm going to draw a couple of pictures of these. I am not going to draw them in losses. I'm not going to draw them in break even. That is something you should be able to do. It's just not something where I feel like it's going to be super helpful for us to have a whole bunch of pictures drawn here. If you do need that, I've actually included those in the Unit 4 video where you could go back to Unit 4 playlist and check it out. So let's go ahead and get started with drawing these two pictures. The first one says a natural monopoly in profit. So again, AP 2020 you're not going to have to draw, but there's a really good chance you're going to have to interpret. So I think it's a good idea for us to take a look at these pictures. Price and quantity, and the demand for the product here, right? And it's a downward sloping demand curve because this is the market and the firm. And then we're going to notice that for a monopoly, they have a marginal revenue curve that separates. Now, in other videos I've done, it explains why that happens. And it's useful to know that the reason that MR does not equal demand anymore, that we left Mr. DARP behind, is because of what we call that they are not price discriminating. Not price discriminating. And again, that's something to go back and kind of quickly review, but we are going to have a picture down here of what that looks like. So that's going to come back in a few. And the other thing to know is that the demand is actually what sets the price. So that's going to help us out. Now, the firm has a downward sloping ATC. So it kind of does one of these. And even though that's starting to flatten out, we'll just kind of say, sure, it's an ATC. And then we'll actually, just to keep it simple, we'll draw an MC curve right here, which basically means that every time they generate an additional unit of this product, the cost stays the same, or virtually the same. And a more technically accurate picture would be like ATC and MC. They look like that. But I'm kind of simplifying it. And in fact, on the AP, they sometimes, so I'm going to leave that here and say ATC, MC. And sometimes on the AP, they'll even give you one where it's like, that's the MC and it's equal to the ATC. And that's super simple. And it breaks some rules, but whatever, we don't really care. It's mathematically not breaking rules, but it's unlikely that would exist in reality. So this is the picture I'm drawing over here on this side is kind of a compromise between the two. Now, we're going to identify the quantity and the price that they're going to produce at. I'm going to switch to a different color so maybe you can see this a little bit better. They're going to produce at MR equals MC. So where is that? Well, here. That's the quantity, QE. Now, we have to go all the way up to the demand curve to see the price. Right? That price is set by the demand curve. So this firm is a price maker in some sense. They get to profit maximize by choosing that price, and it's artificially high, but they're also still limited by the demand. They have profit, and we're going to shade that. I'm going to shade that in green. It goes from the price to the ATC. So just like with before, you still have price to the ATC telling us what's the profit. Okay, and then the next part, it says deadweight loss. There is deadweight loss associated with a monopoly, and in any imperfectly competitive one, they typically have deadweight loss. And that's the transactions that didn't happen that should have. Now, in order to do it, you actually have to know where they should have been producing. So actually, before I do that, let's identify that point. And that point is called socially optimal. Socially optimal. And that occurs where marginal cost equals the price. So one other, I'm going to add to that and say where MC equals the price or where supply equals demand. And in fact, if we remember, the marginal cost curve is the supply curve. So this is the socially optimal quantity, Q opt, and this is the socially optimal price. It's at the marginal cost. So sometimes we actually call it marginal cost pricing. It's to be socially optimal. Now let's switch back and do the deadweight loss. Now it's the value of the transactions that didn't happen. So it goes from the supply curve to the demand curve, and it's the value of these transactions between QE and Q opt. It's the value of the transactions kind of between QE, Q opt, going from the supply curve to the demand curve. And I'm actually going to annotate and put in there MC equals the supply curve. Now, the last part says fair return or break even, right? Or break even. We're going to switch one last time here. And this one, Q fair, P fair would be P equals the ATC. And it's sometimes called fair return just because it's like, well, they're breaking even. That means they're earning normal economic profit and positive accounting profit. And that would occur where price equals ATC. So we follow the price, which is the demand curve, and we locate it where it intersects here. So this is what we call the fair return. Okay, and so I'm going to put another dashed line down here and put Q fair, and dashed line over here and put P fair. And I know that's a little bit hard to read. It's unlikely you're going to ever be asked to draw all of that in one graph, but it is important that you kind of see the different spots. Notice that if they produced it P fair and P and Q fair, they would still have deadweight loss. They would still have some deadweight loss. I'm going to shade it here. It's this tiny little box. That would be a tiny bit of deadweight loss. And so often we regulate natural monopolies to that level. Now let's take a look at an artificial monopoly in a similar situation here. Okay, but the graph's going to look a little bit different. Graph's going to look just a little different. So we have the downward sloping demand. We have that marginal revenue curve coming down faster and faster. And then here's where it's going to be different. In this one, the MC curve is going to be exactly the same as it would be in a perfect competition model, right? And then we're going to say it's earning a profit. So the ATC has got to be below the quantity or below the price at MR equals MC. So before we get into all of that, let's identify the profit maximizing quantity of output and price. And that would be, let me switch back. I'm going to try to stay consistent here with these colors. So we'll see. MR equals MC, we find here, and we go down, QE, and then we come back up, and we go, that's the price, PE. So notice they charge too high of a price, and they don't produce socially optimal still, because socially optimal is, again, where the supply and demand intercept. But at this point, we need our other curve on here. So I'm just going to put in here the ATC, and the ATC has to be below the price at this quantity. So we'll say it's there, ATC. And so the price being above the ATC tells us that the firm's earning a profit. So just like before. Okay. And that ATC could actually be really, really low. It could even be below the point there where MC and MR intercept. It really doesn't matter if you want to make the firm really, really profitable, that's fine. Put it quite low, as long as it still has the swoosh and as long as the ATC comes down and goes back up. And in this case, I've kind of flattened that ATC a little bit, but they look the same. Deadweight loss. So we're going to show that. That's this triangle between the supply and the demand curve over to the socially optimal point. That's our deadweight loss. And then we're going to identify a couple other points here. We've got a socially optimal, and I'm going to try to make that more yellow. That's here. Okay, so this is the opt. Boy, that's a little too hard to see. Let me darken that. I'm still working on this stuff, right? You know, cut me a break. That's the optimal. And so if you were to extend that down, right, you'd have a quantity and all of that stuff. And then fair return is actually in a different spot. I mean, it's still P equals ATC, but it's over here. So fair return. And if we actually regulated them to fair return, we'd have deadweight loss as a result. You'd have too many transactions occurring at that level of quantity. So that's kind of an interesting aspect of this. So this one is quite similar. There was one last thing that I want to tell you about with these, and they sometimes ask, where is TR maximized? TR max. So I should have put that in here, but I didn't. TR max. And that would occur here, TR max, where MR hits 0, where MR equals 0. On the x-axis, right? On the x-axis. And so that's the quantity at quantity 0, where total revenue is maximized. So it's also on this graph, it's up here. So that's the last thing to check out there. All right, now let's talk a little bit about price discrimination. So price discrimination is the idea of charging different consumers different prices based on their willingness to pay. And so there's no set one price. That's the first thing to observe. But it eliminates deadweight loss because it allows the firm to charge prices at the different levels of marginal cost. So in other words, they're going to produce all the way over to the demand equals supply. Another way to say this would be that it makes MR equal demand. It makes the marginal revenue equal the demand again, which is equal to the price. So that's why that happens. Now, a quick picture of what that would look like, right? A perfectly price discriminating monopoly, like this. And instead of having the demand and the marginal revenue be separate, it would be over here, price, quantity, and I'm going to draw an artificial one here. Marginal cost equals the supply. And so now, right, they're going to produce where MR equals MC, which is at the socially optimal quantity. All right. Now, if they had ATC doing one of these, right, they would have a huge amount of profit. They would be doing quite well, in fact. So let me shade that for you. They come from here down to the ATC and then over, and then all of this area is all profit. So it's pretty good. It doesn't include that little nubbin at the bottom there, but it's quite profitable to be a price discriminator. Now, besides allowing price discrimination, two other ways to increase efficiency is public ownership, which would basically allow government to set the quantity at socially optimal. Okay, and the other is to use price regulation, like set a maximum price at the P fair or at P opt is the other way to do it. So hopefully this helps you. I'll see you next time.